Okay, let's switch to the back side of the sheet, another forces review sheet, and I had asked you to do 1 to 4, I believe. So in the first one, it's a 40 kilogram box. It's being pushed forward. You have the coefficient is 0.25, and the acceleration is 3 meters per second squared, and it wants the force it's being pushed with. No forces at an angle this time. If we start in the y direction, it's not moving. And so we find out that Fn minus Fg equals 0. So Fn equals Fg equals mg, which you could find, but you don't need to. You can carry the numbers until later, okay? So just trust me on that and try it. It doesn't make it wrong if you found it. I just want you to try to get used to carrying letters to help you when you have to solve for like a mass. So then if we go to some of the forces in the x, we have F minus friction is equal to max. And we're solving for F, so take your friction over. So F is equal to max plus friction. But what is friction really? It's just mu Fn. And you could have found it in a separate step, but you didn't need to. You can find it right here, right? And then what's Fn? It's mg. So you could do this all in one step and only fill your numbers in at the very end. So it's okay if you didn't. It's okay if you put in 40 here and you multiplied 40 by 9.81 and you got down here 392.4 newtons, and then you multiplied that by your 0.25. But you could do it all right here, right? So you could do 40 kilograms, and what was the A? 3 times 3 meters per second squared plus 0.25, 40 kilograms times 9.81 meters per second squared. So 40 times 3 is 120 newtons, and 0.25 times your friction that you, if you had found it separately, was 98.1 newtons. And so when you add them together, you get 218.1 newtons. Okay? Number 1. Number 2 is a curling stone. So it says that it's thrown forward on the ice. So its initial velocity, come on, focus, there we go. Its initial velocity is 14 meters per second. It travels 49 meters before coming to a stop. From this, we can find our A, because we know Vf squared is equal to Vi squared plus 2A delta D. So rearranging, A is equal to Vf squared minus Vi squared over 2 delta D, and the Vf goes to 0. So A is equal to negative 14 meters per second squared, that squared isn't there, it's up there, over 2 times 49. So on the top, 196 divided by 98. And it works out to be a nice perfect, and it's in the x direction, negative 2. Negative because it's slowing down, okay? All right, so then we go and we look at the forces here. So there's no forward force once you let the curling stone go. The only thing that's stopping it is friction, okay? So that you don't slide down the ice and continue to push it. And of course, in the y direction, there's Fn and Fg. So we'll end up with Fn minus Fg equals 0. So Fn equals Fg equals mg. Even if you wanted to this time, you cannot find this because I didn't give you the m. So another reason why you should try to carry your letters so that when you get to this point, you're not like, ah. So if we go to some of the forces in the x direction, the only one is friction, and it's acting backward. So minus friction is equal to max. But friction is just mu Fn equal to max. And Fn is just mg. So minus mu mg is equal to max. The m's cancel. Mu will be equal to ax divided by negative g. A is negative 2. G is 9.81, and it's negative. So divide your 2 by 9.81 and get a mu of 0.20387. Done. hopefully these are getting fairly easy by now. Speaking of which, number 3. So it's a pulling again at an angle. So it's upward. So our Fx is going to be the cosine. So it's going to be 120 newtons cos of 30. Skipping steps. Fx is equal to, can't do that one in my head, 103.923 newtons. Fy I can do in my head, because it's just sine. So 120 newtons sine of 30, and sine of 30 is just 0.5. So Fy is 60 newtons. Okay? Questions looking for mu. Start sum of the forces in the y direction equal to MAY. It's not moving in the y. So Fn minus Fg plus Fy equals 0. So Fn is going to equal Fg minus Fy. Fn equals 20 kilograms times 9.81 meters per second squared minus the Fy we just found, which was 60. This is going to be 196.2 newtons minus 60. So Fn equals 136.2 newtons. Going to the sum of the forces in the x direction, we have Fx minus friction equals Max. And we're solving for mu, so take this over. So Fx minus Max is equal to friction. And again, I would encourage you, rather than solving for this, solving for friction, instead fill it in as mu Fn. And then you can divide both sides by Fn. So you'll have mu is equal to Fx minus Max over Fn. Fx we found to be 103.923 newtons. M was 20 kilograms. A was 3.5 meters per second squared. And the Fn we found a moment ago, 136.2 newtons. So this is going to be 70. So on the top, 33.923 divided, right, 70, yeah, 33.923 newtons over 136.2 newtons. So you should end up getting a mu of, if I can believe my answer to save time, 2490. If I could see my answer, 7. Okay. 1 to go. You're pushing down at an angle this time, and you're looking for A. So again, Fx should just be 300 newtons cos of 36.87. So Fx should be 240 newtons. Fy, 300 newtons sine of 36.87. So Fy should be 180 newtons. Go to sum of the forces in the y direction equal to 0. Fn minus Fy minus Fg. So Fn equals mg plus Fy. And just because I'm going to run out of time here, you should end up with Fn to be 392.4 newtons plus your 180. So Fn is equal to 572.4. Go to the x direction. So Fx minus friction equals Max. So A is going to equal your Fx 240 newtons minus mu Fn over m. So 240 newtons minus 0.3 times 572.4 newtons over 40 kilograms. And you should get an AX of 1.707. Okay? All good? So you could have found this separately, but you didn't need to. Okay? You can just